Hello, good day students. We are going to continue with our physics lecture in which we are doing mathematical methods where we are studying vector analysis. In the last lecture we have studied two types of vectors in which we have studied what is a zero vector. A vector in any direction with magnitude equals to 0 will become a zero vector, which is also termed as a null vector, and the resultant vector. Okay, so which is a single vector which will give the same effect as that would be given by two or more vectors. Today we will go for the next type of vectors, in which firstly we are going to deal with what is a negative vector or opposite vector. So this is the third type of vector into consideration. Negative vector or opposite vector. Now what is a negative vector or opposite vector? We define it as a negative vector of any given vector the same magnitude but opposite direction. What are we saying? A negative vector of any given vector. So negative vector will be for a given vector. So let me have a vector with me. Say I have this as vector A and I take the magnitude of this vector A. What am I taking magnitude of the vector A? Say I have the magnitude of this vector in this direction equal to, so this is the magnitude of the vector, and let me take this equal to 10 centimeters. How much is the magnitude? 10 centimeters. Let us take this as a displacement vector. So this is the displacement vector in this given direction, which is denoted by this arrowhead, and magnitude of this vector is 10 centimeters. Then the negative of this given vector A will be a vector having the same magnitude but opposite direction. So, if I draw another vector of the same magnitude, magnitude is going to remain the same. Okay, दोनों का magnitude same होगा, but directions कैसे होगी? Exactly opposite. So now I am having this as, say, vector B. Okay. Again, if I have magnitude of vector B equal to 10 centimeters. So what am I having over here, students? The two vectors are having the same magnitude but opposite direction. Then these are said to be negative vectors of each other. So I will say vector B is the negative vector of A, or vector A is negative vector of B. Therefore, how can I write? Vector A is equal to minus vector B, or I can also write vector B is equal to minus vector A. Getting it? So when these two vectors get added up, their directions will cancel each other and the resultant magnitude of the vectors will be equal to 0. Are you getting it? So a negative vector of a given vector is a vector having the same magnitude but opposite direction. Okay? Then we'll pass on to the next type of vector, and that vector is equal vector. So let me explain to you what do we mean by equal vector. Now when we say equal vector, then it should come in our mind that vector is a directional quantity, and for vectors to be equal, two aspects should be the same. They should have the same direction and they should have the same magnitude. So that is what is the definition of equal vectors. So when can I say two vectors are equal? So I can say two vectors representing a physical quantity are said to be equal if and only if they have same magnitude and same direction. So two vectors which are representing the same physical quantity, a particular physical quantity, are said to be equal, conditioned if and only if they have the same direction and they have the same magnitude. Okay? Say for example, if we take, let vector P and vector Q be force vectors. What are we taking this? We are taking this as force vectors. That means these are the vectors representing force. Then if vector P is in this direction, this is vector P, such that magnitude of vector P is equal to 5 newtons, then vector Q, which is also in the same direction, such that magnitude of vector Q is also equal to 5 newtons, their directions are same, their magnitudes are same, then I can say vector P is equal to vector Q. Okay? So, what are equal vectors? Two or more, not necessarily two. Two or more vectors which are representing a physical quantity are said to be equal if and only if these vectors are having the same magnitude as well as the same direction. Are you getting it? So both these definitions and explanation you need to take down, note it down. These are all important aspects, points from the view of examination. Okay. So now we'll pass on to the next type of vectors in vector analysis. Now we'll go for another important vector type, that is position vector. What are we going to study, students, now? Position vector. Now what is a position vector? The position vector is a vector which gives the position of a point. It gives the position of a point with respect to the origin. Position of a point with respect to the origin of a chosen, selected coordinate system. So let me first make you understand this and then we will write it down. So what are we saying? Position vector is a vector which gives the position of a point with respect to a selected origin. Now this origin is of the selected coordinate system. Okay? What do we mean by this? Let us consider a point over here. Let me take this as point P. Now I want to specify the position of this point. And for that, what am I selecting? I am selecting a coordinate system of x-axis and y-axis, say. So, this is the x-axis. And here I am having the y-axis. Right? And you all know that the point of intersection of this is the origin O. So here I am having the origin O. Now, this is vector OX in this direction, and perpendicular to it, let me take this as vector OY in this direction. Now what am I doing? I am joining this origin of the coordinate system with the point P. So I join it over here and extend it. So what am I having over here? I am having vector OP. Okay. So with reference to this point O, which is the origin of this coordinate system which I have selected, the direction of the point P will be represented by this vector OP. Right? So I get the position of this point P in the coordinate system. Then this vector OP becomes the position vector. What is it? Position vector. So let me write down what is the position vector. A vector which gives the position of a point a vector which gives the position of a point or a particle, okay, with respect to, so this point will be representing, say, a particle in motion, okay. This particle, say, if it is in circular motion, moving like that, at this instant it is at this point, next instant it will be here, next instant it will be here. Accordingly, the position vectors are going to change, okay. So a vector which gives the position of a point, that is a particle with respect to origin, with respect to origin of a selected or a chosen coordinate system is called, what is it called? Position vector. What are we going to call it, students? It will be called position vector. Okay. Now, here this position vector generally will be denoted in. In fact, when I give the position vectors, the denotation of a position vector will be in small case. So I can write here, position vector OP is equal to vector R. Okay, so For the vector OP, vector R becomes what? The position vector. So here I am denoting the position vector of this vector OP as vector R. Are you getting it, students? Okay. Now from the position vector, we pass on to the next type of vector, and that is a unit vector. What is it? A unit vector. You have to write down those definitions. Everything should be there in the notebook. Okay. So you have to prepare your own notes. So take down these definitions, their explanations should be there in the notebook. Okay, students? Now let us pass on to the next type of vector, and that is unit vector. What is it? Unit vector. See, in physics, this term unit will carry certain meaning. Okay, when we say unit of a physical quantity, that means it will be the expression to that physical quantity in terms of the system of measurement. Like if we are measuring mass in CGS system, then unit of mass will be gram. In MK system, unit of mass will be kilogram, and so on. That is unit of a physical quantity. Okay? But when we use unit as an adjective, like a unit vector, unit magnitude, or magnitude is unity. When we say it that way, their unit or unity means 1. What is the value over there? 1. So when I say unit vector, that means it is the vector whose magnitude is equal to 1. वो वेक्टर जिसका मैग्नीट्यूड 1 हो. ओके, इसका मतलब डिस्प्लेसमेंट वेक्टर वो 1 सेंटीमीटर का हो सकता है, 1 किलोमीटर का हो सकता है, 1 मिलीमीटर का हो सकता है, 1 डेकामीटर का हो सकता है, पर वैल्यू कितनी है मैग्नीट्यूड की? 1. If it is a force vector, it will be the vector of 1 dyne or 1 Newton. Are you getting it? If it is a velocity vector, that means the value of this vector will be 1 centimeter per second, 1 meter per second, 1 kilometer per second, magnitude becomes 1. Okay? So, a unit vector is a vector having unit magnitude in the given direction. So, what is it? A unit vector is a vector having unit magnitude, unit magnitude in a given direction is called unit vector. What do I call it as? Unit vector. What do I mean by this? Say for example, I am having a vector. Okay, this is vector F. And magnitude of this vector F is equal to, say, 10 newtons. It is a force vector. Magnitude how much? 10 newtons. Now what am I doing? I am having another vector in the same direction. another vector.